Hello space enthusiasts, welcome to Starflicker. In this video, we cover unknown topics about the ISS, spacewalks, the ISS mission, and technical information about the station. Feel free to share your thoughts and ideas in the comments. This gigantic space station orbits our planet 400 kilometers above our heads at 28,000 kilometers per hour, making a full revolution every 90 minutes. And inside, 6 to 7 crew members carry out missions and experiments. The International Space Station is like a giant city in orbit, with a complex and powerful system that draws its energy entirely from the sun. Power is generated by giant solar panel blades, each of which is about 35 meters long and 12 meters wide. There are 8 of these wings in total, and they are symmetrically placed on either side of the station. Total power capacity: these panels can generate up to 120 kilowatts of electricity when the station is in direct sunlight. This is enough to meet the instantaneous electricity needs of more than 40 homes on Earth. This capacity has been further increased in recent years with the addition of new, more efficient panels called IROSA. The panels are mounted on rotary joints called alpha and beta that can continuously follow the sun. This allows the panels to face the sun at the most efficient angle, even as the station orbits. The station's power is generated by 8 massive solar panel blades, each 35 meters long. These panels can generate up to 120 kilowatts of electricity by continuously tracking the sun. This capacity has been further increased with the recent addition of IROSA panels. Storage: the ISS spends about 35 minutes of its 90-minute orbital tour in Earth's shadow. The energy needed during this dark period is supplied by 24 modern lithium-ion batteries that store electricity generated during the sunshine. Distribution: the 160 volts of high-voltage power generated and stored is distributed to the station via a 13-kilometer cable network and reduced by special converters to 124.5 volts for use by equipment. The system has 8 independent power channels, providing maximum safety and redundancy against any failure. How does the ISS stay in orbit? Altitude and attitude control systems. The International Space Station, ISS, is in a constant battle against the invisible drag of Earth's atmosphere. 2 ingenious systems work together to ensure it stays in orbit and points the right way: massive gyroscopes and powerful rocket thrusters. Attitude control: gyroscopes. The station's precise orientation is handled by giant, spinning wheels called control moment gyroscopes, CMGs. Without using a single drop of fuel, this system adjusts its spin speed to rotate the 450-ton station with the grace of a ballerina, keeping its solar arrays locked onto the sun and its antennas pointed at Earth. Altitude control: rocket thrusters. To counteract the atmosphere's braking effect, the ISS must periodically get a reboost to a higher altitude. This is done using powerful rocket thrusters fired by either the station's own Zvezda module engines or by docked spacecraft like the Progress cargo vehicle. These firings are vital maneuvers that prevent the station from slowly falling back to Earth. What happens on the ISS? The 3 core missions. The International Space Station, ISS, is fundamentally a science laboratory in orbit, serving 3 primary purposes. Scientific research. The station's most critical mission is to conduct experiments in the unique microgravity environment, research that is impossible to perform on Earth. These studies focus on areas like human health, studying the effects of long-duration spaceflight and researching diseases; physics, developing new materials and alloys; and farming in space. Earth and space observation. The ISS provides a unique vantage point for observing our planet. It tracks climate change, monitors natural disasters, and hosts telescopes to study the universe. Maintenance and future preparation. The crew performs constant maintenance and repairs on the station's complex systems and conducts spacewalks. Crucially, the ISS also serves as a critical test bed for new technologies needed for future missions to the Moon and Mars. In essence, the ISS is a multi-purpose outpost that pushes the boundaries of science, watches over our planet, and prepares humanity for its future in space. This NASA-led project is one of mankind's greatest achievements in science and technology. What part of its mission impresses you the most? Share your thoughts in the comments.